Hi friends, welcome you all to Think Max. We are in class 10 Max, chapter 11, areas related to circles. In this session, we are going to discuss about example problems. So first example, find the area of the sector of a circle with radius 4 centimeter and of angle 30 degree. Also, find the area of the corresponding major sector. We have to use the value of pi as 3.14. So please note that if you are using the old book, this is example number 2. So example 1 is deleted syllabus. So this is example number 2 in old book. So in new book, it is example 1. So what is given? We have to find out the area of the sector with radius 4 centimeter and of angle 30 degree. So for a circle, we will have the center O. So we will draw the radius, 2 radius. So area of the sector is formed by the area formed by 2 radius and the corresponding arc. So this is the sector. So let us name this point as A and this point is B. So let us take a point P in this R. So we have to find out the area of the sector O, A, P, B. So this is the first part. Area of the sector, just sector means it is nothing but minor sector. Next question, also find the area of the corresponding major sector. So this is the major sector. So this shaded portion is the minor sector. This unshaded portion is the major sector. So first let us find the area of the minor sector. So let me start the solution. So what are all given? Radius R is equal to 4 centimeter. Theta is 30 degree. So this angle makes 30 degree. So theta is equal to 30 degree. We have to use pi is equal to 3.14. So these are the data given in the question. We have to find out area of the sector. So sector means minor sector. So area of sector O, A, P, B. So what is the formula for area of sector? It's nothing but theta by 360 into pi r square. So what is theta? 30. So 30 by 360, pi is 3.14 into r square. What is r? R it is 4. So it is 4 square. So we can cancel the zeros. So 1 3s are 3, 12 3s are 36. So it is 1 by 12 into 3.14 into 4 square is 16. 4 square is nothing but 4 into 4. 4 into 4, it is 16. 4 square is 4 into 4. 4 into 4 is 16. So now let us calculate now. So this 12 and 16 have the common divisor 4. So 3 4s are 12, 4 4s are 16. So remaining we have 3.14 into 4 in the numerator. In the denominator we have 3. So if you multiply 3.14 into 4, 4 4s are 16, balance 1. 1 4s are 4, 4 plus 1, 5. So there is a decimal place. So keep your decimal. 3 4s are 12. So it is 12.56 divided by 3. So if we divide 12.56 by 3, let us calculate here. 12.56 divided by 3. So 4 3s are 12. So 0, 12 minus 12 is 0. Put the decimal. So decimal comes down. So next number is 5. So 1 3s are, so we have to put the decimal. So we have started with the decimal. So put the decimal here. Okay. So no need to put decimal here. So just bring the number down. So this decimal can be placed in the quotient. So 4 point. So 5 we have come down. So 1 3s are 3. So 3. 5 minus 3 it is 2. So bring this 6 down. So it is 26. So 8 3s are 24. Balance is 2. So put 1 0. Already decimal is there. So no need to put a decimal for this 0. So it is 6 3s are 18. Again it is 2. So you have to add 1 0. So it is 6 3s are 18. So again It goes on like this, it will not stop. So as it is, remainder is 2 always, so it will not stop. So it is equal to 4.1866 can be approximated to 7. So if you approximate to 2 decimal places, it is 4.19. So this decimal is greater than 5. So you can add one number here. So 1.49 centimeter square. So this is the area of the minor sector OAPB. Now next question, we have to find out the area of the major sector. So two ways you can find. So what is the angle of the major sector? Angle of the major sector is 360 degree minus theta. So we can use that angle and apply the formula and find out the area of the major sector. Another method is from the full circle area, if we subtract the area of minor sector, you will get the same answer. I am going to use the formula. So now angle of the major sector equal to 360 degree minus theta. So 360 degree, theta is 30. So it is 330 degree. Now area of major sector. Now let us name the point in a major sector as Q. So now it will become OAQB. OAQB equal to, so the same formula theta by now. Theta is here 330. So 330 by 360 into pi r square. Pi is 3.14. R is 4. So it is 4 square. So zeros gets cancelled. 11 threes are 33. 12 threes are 36. Now we will have 11 into 3.14. 4 square is 16 divided by 12. So 16 and 12 are divisible by 4. So it is 3 4s are 12, 4 4s are 16. So we will get 11 into, what is 3.14 into 4? Already we calculated 3.14 into 4 is 12.56. 12.56 divided by 3. Okay. So 12.56 divided by 3 is 4.19. So we can write 11 into 12.56 divided by 3 is 4.19. So now what is 11 into 4.19? Let me do the calculation here. So 11 into 4.19. Instead of writing 11 into 4.19, we can write 4.19 into 11. So 4.19 into 11. So if you multiply by 1, you will get 419. Again multiply by 1, you will get 419. Adding 9 here. 1 plus 9 is 10. Balance 1. 1 plus 4, 5. 5 plus 1, 6. This 4 comes here. How many decimal places? 1, 2. So it is 46.09. So 46.09 or approximately 46.1 centimeter square. So this is the area of the major sector OAQB. Okay children, do you understand? So let me go to next example. Example 2. Find the area of the segment AYB if radius of circle is 21 centimeter and angle AOB is equal to 120 degree. We have to use pi is equal to 22 by 7. So this figure is given. So circle is there. Radius of the circle is 21 centimeter. So O is the center of the circle. OA and OB are radius. So radius is given as 21 centimeter. So OA and OB will be 21 centimeter. Angle AOB is equal to 120 degree. So I took a point Y. So point Y is in the sector OAYB. Okay children, what we have to find out? We have to find out area of the segment. So this portion. So AB is the chord and arc. Between them we have the area of the segment. So area of the segment means it is nothing but minor segment AYB. So how will we find the area of the segment? We have to subtract from area of the sector OAYB minus triangle AOB. So from the area of the sector OAYB, we have to subtract area of the triangle. Okay, children. So there is no direct formula to find out the area of the segment. So area of segment AYB is equal to area of sector. So from area of sector OAYB, if we take out the area of triangle OAB, then we will get this segment area. So first we are going to find out area of sector. So area of sector OAYB is equal to theta by 360 into pi r square. So what is theta? Theta is 120 degree. So 120 by 360, pi is taken as 22 by 7. What is r? R is 21 centimeter. So 21 square. So zeros gets cancelled. 1 12s are 12. 3 12s are 36. So we will have 22. I'm sorry. So first part is 1 by 3. 1 by 3 into 22 by 7 into this 21 square can be written as 21 into 21. So here 1 sevens are 7. 3 sevens are 21. So these two 3's gets cancelled. So we will have 22 into 21. So what is 22 into 21? Let me calculate here. 22 into 21. 22 into 1 is 22. 22 into 2 is 44. So 2 plus 4, 6. This 4. So it is 462 centimeters square. So area of the sector OAYB is 462 centimeters square. Next we have to find out the area of the triangle AOB. So here this angle is 120 degree. So we know the sine values for 0 to 90 degree. So as the angle here is 120 degree, we cannot use the formula 1 by 2 r square sine theta. So we can use the formula half BH. So area of the triangle half BH. So we must know the base value and the height. So we are going to draw OM perpendicular to AB. Okay, children. So we are going to draw a line OM perpendicular to AB. So next part is to find area of triangle OAB. So we have to draw OM perpendicular to AB because the angle here is 120 degree. So we cannot apply the formula 1 by 2 r square sine theta. So as theta will take 120 degree, sine 120 degree. So in this 10th standard, we are not able to find sine 120 degree. So we are going to draw OM perpendicular to AB. Okay. So now we are going to move on to the next step. In the next step, we are going to take the triangles AOM and BOM and prove that they are congruent. Okay. So in triangles AOM and triangle BOM. So what we have? We have angle AMO equal to angle BMO. Both are 90 degree. So this is by construction. Angle AMO equal to angle BMO. Both are 90 degree. So this is by construction. As we draw OM perpendicular to AB. So next So this perpendicular opposite is this one, hypotenuse side. So AO and BO are radius of this circle. So both will take the same value. So radius will be same for a circle. So OA and OB will be equal. OA equal to OB. So this is because radius of the circle. Next one, OM. OM is common for both the triangles. So we can write OM equal to OM. The reason is common. So this is right side, right angle, hypotenuse and a side. So by RHS criteria, we have triangle AOM congruent to triangle BOM. The reason is by RHS criteria. So as we have this congruency, we know their corresponding parts are equal. So what are their corresponding parts? We will have AM equal to BM. So therefore, AM equal to BM. So as both their lengths are equal and OM is perpendicular, this OM will be the perpendicular bisector of AB. So since their lengths are equal, length of AM and BM are equal and OM is perpendicular by construction, then OM will be the perpendicular bisector. So both their lengths are equal. So M is the midpoint of AB. So this means M is the midpoint of AB. So what happens to the angle AOM and angle BOM? As both are congruent, their angles will be equal. So angle AOM will be equal to angle BOM. So this is because by CPCT, corresponding parts of congruent triangles are equal. So angle AOM will be equal to angle BOM. So their complete angle is 120 degree. So let angle AOM is equal to A. So if it is A, angle BOM will also be A. So A plus A will make 120 degree. So if this is A, this also will be A. So A plus A is 120 degree. So 2A will be 120 degree. A will be equal to 120 by 2, which is 1 2 are 2, 6 2 are 12, this is 0. So 60. This means angle AOM equal to angle BOM will be equal to 60. So this angle is 60 degree and this angle is also 60. So far we got this data. Now we have to find out the value of OM. This perpendicular, that is height of the triangle and base of the triangle, so that we can find out the area of the triangle using the formula half BH. So let us do that in the next page. So far we got area of sector as 462 degree and these two angles are 60 degree by the congruency of triangle AMO and triangle BM. So we got this. So now we have to find out the value of OM. So let us use any one triangle. So from triangle, which triangle? Let me use this AMO. From triangle AMO. So now we need to find OM. First, height. What we know? We know OA. So this is right angle. So this is the hypotenuse side and angle opposite is, this is the 60 degree opposite to this angle. So this is the opposite side. So this will be the adjacent side. So we know the hypotenuse side and we have to find out the adjacent side. So these two relation, adjacent and hypotenuse. What we know? We know the relation some old hippie, O by H, old hippie caught another hippie tripping, so T, tripping on acid. So sine is for O by H, cos is for A by H, tan is for O by A. So O stands for opposite, H for hypotenuse, A for adjacent. So we have to find out the relationship between adjacent side and hypotenuse side. So adjacent and hypotenuse is for cos. So we have to use cos 60 degree to find OM. So cos 60 degree equal to adjacent side by hypotenuse. So which is the adjacent side? OM. OM by hypotenuse side is OA. So what is cos 60? Cos 60 is 1 by 2. So 1 by 2 is equal to OM. We need to find OA is 21. So just cross multiply 2 into OM equal to 21 into 1. So it is 21. So OM equal to 21 by 2 centimeter. So we got the value of the height of the triangle. Next we have to find out the base. To find out the value of AB, if we find out the value of AM, it is enough because AM and MB are equal. As M is the midpoint of AB, AM and MB are equal. Okay, children. So to find AM, so AM is in the opposite side. So we know the hypotenuse side. So which marks opposite and hypotenuse? We can use sine. So sine 60 degree equal to opposite by hypotenuse. You can use tan also because we know we found out the adjacent side also. So you can use tan 60 is equal to O by A. Both will give the same answer. I am going to use the sine 60 degree. So sine 60 is root 3 by 2. So root 3 by 2. Opposite side is AM. Hypotenuse side value is 21. So AM by 21. So cross multiplying 2 into AM equal to root 3 into 21. So AM equal to root 3 into 21 divided by 2. So we can write it as 21 root 3 by 2. So AM and MB are equal. So this means BM will also be 21 root 3 by 2. So AB is nothing but AM plus BM. So AM is 21 root 3 by 2. BM is 21 root 3 by 2. So which is equal to, so both have the same LCM 2. So 21 root 3 plus 21 root 3 is 42 root 3. So 1 2s are 2. 2 2s are 4, 1 2s are 2. So it is 21 root 3 centimeter. So we have AB is equal to 21 root 3 centimeter. So we found out the value of the base and we found out the value of the height. So area of triangle AOB is equal to 1 by 2 into base into height. So 1 by 2 into base is AB, height is OM. So 1 by 2, what is AB? AB is 21 root 3 OM. OM is 21 by 2. So it is LCM we have. We cannot cancel anything here. So we have 2 into 2. 2 into 2 in the denominator. So it is 4. In the numerator, we have 1 root 3. 21 into 21. What is 21 into 21? So we can easily calculate. So if there is a square here, so 21. 21 we can reduce to tens place by subtracting 1. What is the opposite? It is plus 1. So 21 minus 1 is 20. 21 plus 1 is 22. So multiply this. Zeros come. 2 into 22 is 44. What number we subtracted and added? We added 1. What is the square of this? 1 square. 1 square is 1. So adding this we will get 441. So it is 21 square is 441. Okay. So 21 into 21 is 441. So 441 root 3 by 4. So this is the area of triangle AOB. So what we have to find out? We have to find out the area of the segment AYB. So what is the formula? Let me go to the previous page. Area of the segment AYB is equal to area of sector minus area of triangle. So we found out the area of the sector as 462. In the next page, we found out area of triangle AOB. Okay. So now applying this, let me erase this. So area of segment AYB is equal to area of sector. What is the area of sector? 462 minus area of triangle 441 divided by 4 into root 3. So here we have 21 as the common. So if we take 21 outside, so here two 21s are 42. So two 21s are 42. So 46 minus 42 is 42. So it is again 2. So two 21s are 42. So 22 minus. So we took 21 here. So 21 into 21 is 441. So 121 is taken outside. There will be another 21 divided by 4 and root 3. So now if we take 4 as LCM, so if we take 4 as LCM, so we have to multiply here by 4. So 22 into 4 is 88. So 88 minus 21 root 3 centimeters square. So this is the area of segment AYB. So with this you can stop or you can calculate if root 3 value is given. So here root 3 value is not given. So you can stop with this. Okay children, do you understand? With this example problem is over. In the next video, we will discuss about the exercise problems. Okay children, thank you. Thank you for watching.